Hey everyone, considering the definite integrals, this will be for the H2 Math students because I'll be covering definite integrals for your integration by part. So we know what definite integrals are, right? So it's basically you having your limits. So you having your limit, then your function, and let's say we have a function x, so it will be dx. So what happens if we have a definite integral for a function that requires us to use integration by parts? So let's see. For example, we have integrating 1 to 3, and we have this function x times e power x dx. Okay, so clearly there's no directly integrable form. We have to use integration by parts. So obviously, you integrate ex first, right? Because if you integrate ex, you'll get back ex. So we integrate ex first, we get back x ex. So what do we do here? Because we have already gotten the final, quote unquote, final integral, we will have 1 and 3. Now, minus away, differentiate the other, differentiating x, we keep the limits, we get back just ex. For afterwards, you can just sub in the values now for the x ex. Alternatively, you can solve everything throughout first. So if you want to solve everything throughout first, you'll get this. Alright, now we put in the values, we get 3e cubed minus e minus away e cubed plus back e. Okay, then we simplify, you'll get 2e cubed. Alright, now we've covered the limits for integration by parts. What about, let's say, for our integration through substitution? So for instance, we have this integral, well, let's say our substitution is x equals sine u, and we have the limits 0 to 1. Alright, then the function is actually 1 minus x squared dx. Alright, what do we do now? So first we put in substitution first into the function. We'll get root 1 minus sine square u. Then we must also differentiate, right? So we find dx du, which will be simply cosine u. So times cosine u. Now this will become du. What about the limits, right? Because the limits were in x, right? Because your variable originally was x, but now you're integrating with respect to u. As such, you must change the limits to also in terms of u. What do? We just sub in, all right? So if x equals to 0, 0 equals to sine u, u is equal to 0. If x equals to 1, well, it's quite simple, right? U is simply pi over 2. So if you just put it in there correspondingly, so we get integrate from 0 to pi over 2, root 1 minus sine square u, the whole thing times cosine u. And then you simplify. You'll get back cosine square u du. Reason why it's cosines, u was the reason why there's no modulus, because 0 to pi over 2 is in the first quadrant. Therefore, if we can have root cosine square u, since it's in the first quadrant, we know that cosine u is positive. Therefore, we can just immediately write down cosine u positive times cosine u positive, giving us back cosine square u. So do be careful when you use integration by substitution, especially when it comes to trigonometry. Then we just simply apply our double angle formula, so that we know that cosine square u equals to cosine 2u plus 1 over 2 du. Then we just perform our basic integration. Sine 2u over 4 plus half u, 0 pi over 2. How do you get sine 2u over 4? Basically, cosine becomes sine, right? In integration. Then you must also divide by the derivative inside our trigonometry, which is 2u. So a differentiate is gives me back 2, and you divide by another 2. So divide by 2, giving divide by 4. Sine 2u, so you put in the limits again. So sine 2u, I put in u equals to pi over 2, I get sine pi, which is 0, so I get 0, plus half u, so I get pi over 4. Now I substitute in 0, sine 0 is again 0, half 0 is again 0, so I'll get pi over 4. So yeah, when it comes to integration by definite integrals by substitution, you must always change the limit to the variable. Change limits to the variable, to the new variable. Alright, so there we have it, the definite integrals for integration by parts, and integration by substitution.